Hey guys.
Are we good? Are we recording, Kristen?
Yes.
Good. So I'd like to introduce you all to Jeremy Blum. He is known from Cornell University. He did a bunch of cool stuff there, like Pop Shop. He wrote the book on Arduino that we have somewhere around here. He is also worked for MakerBot a couple years ago, and he currently works for Google X Labs. Saying that right? Yeah. Yeah, Google X Labs. But most of all, he's known for being the 2012 BlueStamp Engineering lead instructor. So
yeah, it's true. I go anywhere in the world, I'm like, oh my God, you taught BlueStamp 2 years ago, and yeah.
So it opens doors. Opens doors. Hear that, staff? Opens doors. But he's going to talk to you today about all the cool stuff he does and all the cool stuff he might do. I don't know. Please do ask him in a large amount of questions, because he'll probably have an answer, or at least tell you where to point. Yes. All right.
Cool. So yeah, on that note, interrupt me at any point. I don't care if you raise your hand or just yell it out or whatever. I don't like the whole like I talk for half an hour and then like everyone raises their hand. Just if you have questions along the way, just ask them. They're totally cool and appreciated. Okay. So yeah, my name is Jeremy Blum. I'll give you a little bit of my background first, and then I want to talk a little bit about specifically a lot of the work I do, or how I do work at Google X, which is very much a combination of engineering and art and design and a lot of other things, and why those kinds of things are important. But I'll give you some background first. Dave covered some of it. So I did my undergrad and my master's at Cornell. I finished my master's both in electrical engineering. I finished my master's now a year and a half ago, or a little less than a year and a half ago. And so I was there for 5 years. I love Cornell. If anyone here is thinking about applying to Cornell, I strongly encourage it. And anyone who's not thinking about applying to Cornell, you should be. So I did a lot of stuff there. The first thing I did when I got there was I really wanted to do something hands-on and interesting, and most universities have this in the form of project teams. So there was a project team for building solar-powered houses, and so I joined that. I got really into it, and I did that my freshman year. We built a solar-powered house. We brought it down to Washington, D.C., won a bunch of awards. And then at the end of my freshman year, I took over that team and disbanded it, and turned it into something else, which is this thing over here, Cornell Sustainable Design, which is, if any of you do go tour Cornell or do some research on it or something, I pretty much guarantee you that that will come up. So that organization is now I started about 4 years ago from now. It's now the largest project team at Cornell. It has students from every college at Cornell, Cornell 7 colleges, engineering, hotel school, business, law, all these things, like 25, 30 different majors. And so this program was a lot of the reason why I've been successful in other things, which is that it taught me how to work in an interdisciplinary fashion, which is a lot of what I'm going to talk about today, and working with people who are different skill sets than your own. So not just being heads down and working on engineering stuff, but also understanding the design side of things, the communication side of things, the business side of things. And that's a lot of what BlueStamp aims to teach, so I'm very supportive of that approach in general. But I want to kind of reiterate how important it is. So I did a lot of that. That organization, after I reformed it, we built an award-winning schoolhouse passive schoolhouse in South Africa. We built a sustainable community in Nicaragua. We rebuilt several buildings in Ithaca, where Cornell is. We're the only student group responsible for advising and overseeing development of the Cornell Tech Campus, which is that huge new campus that's being put over on Roosevelt Island. How many of you have heard about that? Cool. So our group worked on that. I was one of the people who helped us win that bid so that we could build that there. That's going to be huge. I think it's going to dramatically change New York City over the course of the next 30 years and make it a lot more like Silicon Valley. So there's a lot of stuff there. I'm happy to go into that more if you have questions about it later. My master's time was spent, the topic of my master's research was developing human-centric lighting systems. And by that I mean, basically I was inventing hardware and algorithms that allow light bulbs to emulate sunlight indoors. So basically what it was is screw-in light bulbs, except they seem like sunlight. And for any of you who have spent any considerable amount of time under fluorescent bulbs, you probably know how much fluorescent bulbs are horrible. They're not great for you from a physiological level because of the wavelengths of light they emit, and what they do to your concentration and sleep habits and things like that. So I spent a while working on that. We spun it off into a startup company called Sun. Again, won a bunch of awards, went through a startup accelerator. That company's still going. I sit on the board for it. And right now we're licensing lighting control algorithms to lighting companies like Philips and GE. Blum DLabs is my consultancy that I also started in college, where I just do design consulting work similar to a lot of stuff that Dave does when he's not teaching all of you. It's the platform through which I do a lot of my educational content, YouTube videos, my book, all those kinds of things. I funnel through Blum DLabs now. Also at Cornell, I worked in the Creative Machines lab. That was the main reason I chose to go there. I had read about it in Popular Mechanics when I was in high school. The lab was building 3D printers. This was long before any of you heard what a 3D printer was. This was 7 years ago. So 3D printers now this big, almost mainstream thing really. So this was like before anyone had heard of them. I was like, I want to work on that. So I did, and I worked in that lab all 5 years I was at Cornell. I did build 3D printers. I made 3D printers that print metal, 3D printers that print cookies, that we did eat and were very good. Structure modifying robots that are published in a number of journals. Basically robots that can climb up cell towers or the International Space Station and reconfigure it in real time. Kind of like a crane that's attached to a building instead of stationary on the ground. So I did a lot of robotics research there. One of my internships when I was in college was at Deca Engineering, which is the company that originally designed the Segway. And it is also known, I worked on specifically the Luke prosthetic arm project, designing electronics for that. Another internship I did, or I started in college and then continued consulting for 2 years afterwards, was MakerBot. So you guys have a MakerBot here somewhere, right?
We have 2.
You have 2. Which ones do you have? You have the replicator too?
Yes.
So I designed the electronics for that. Or rather, I designed the electronics for the replicator 1, and then the replicator 2 electronics are mostly based on them, but I didn't do all of the adjustments for the replicator 2. But I did that. If you take a replicator 1 and flip it over, my name is written on the circuit board on the bottom. Pop Shop was a co-working space we started at Cornell that helps launch student startups. Now a few dozen startups go through it every year, and a lot of them have been funded and have seen a lot of awesome success. It gives a place for people to come and work together. And another passion of mine is posting YouTube videos. How many of you have watched one of my YouTube videos? Okay, decent number. I have the most watched Arduino videos on YouTube by several orders of magnitude. And that's what ended up leading to me writing a book about it, which is also the best rated Arduino book on Amazon. When that came out about a year ago now, and you guys have a copy somewhere. So that's my background. But that's boring, so let's talk about other stuff. So I want to talk about art, which a lot of people think is weird when I come and want to talk to a room full of engineers about art. So I would say myself about 6 or 7 years ago, I was very stereotypical engineer, function always comes before form 100% of the time. I don't care about making anything look good. I don't care about I cared about the design, but it was really like I wanted to make something that was functional and amazing and did a series of things that I wanted to do really, really well. And that's super important. One thing that I want you guys to realize is that as you're doing that, it's actually a very creative form of self-expression to do engineering and to make something that actually operates the way you want it to. And I want you to keep in mind how similar it is actually to art. And you have to be creative, and you have to be, you have to approach problems in a difficult way oftentimes. And it's actually not that different from the way a lot of artists think. And so as I started to realize this more and more through college, I started working more and more with people who are not engineering backgrounds. And I think one of the best decisions I ever made was forcing myself every semester in college to take at least one class that was totally not engineering at all. So whether it was music or economics or introduction to wines or massage or whatever. Some of those obviously are lots of fun for other reasons. But it forced me to spend a lot of time with people who think very differently than my brain personally works. And while I still wouldn't consider myself to be an expert designer or to have like a design-centric brain like many of the designers and user interface designers who I work with, for example. I understand that side of the equation a lot better now, and it helps me to make more informed engineering decisions. And at the end of the day, when you're working on consumer electronics, which is my main thing that I do at Google, working on consumer electronics, at the end of the day, people love things that are functional, but they love things even more that are beautiful and functional, and that's the reason why Apple is successful, because they've gotten really good at merging the two. And so it's not just one or the other, it's the combination of them. So that's what I want you guys to keep in mind. So I have this thing that I kind of stole from BSE NYC, which is a co-working space in Midtown. But it's called Hackers, Hustlers, and Hipsters. And so this is a thought process behind the 3 kinds of people or personalities that you need to make a successful company, project, idea, what have you. So the hackers are the technical people, the people that can say, I have an idea and I want to make it functional and do something as quickly as possible. It can be hacked together, that's why they're called hackers, it doesn't have to be perfect. The hustlers are the people that convince everyone else why this idea is amazing and usually why they should throw money at it. And then the hipsters are the folks who do the design work and make sure that the thing that you're hacking together and the thing that you're selling as being amazing is actually beautifully functional and works the way that people expect it to. In an ideal world, any product you make shouldn't have to come with a reference manual. In my opinion, any consumer electronic device where you need to look through the instruction manual to use it has failed at the design process. And so that's where I think the hipsters come in, for lack of a better term. So the pawn shop was a really good example of this because it was a lot of us who came together who had really, really different backgrounds, and the reason that this was able to become successful is because we were able to approach it from all these different perspectives. So I definitely sometimes fulfill each of these roles, but I'm definitely most heavily in the hacker realm, and you don't have to be just one. Different people have different percentages of themselves that are different parts of these, but the key thing is in any project having equal parts of all of them, I think. And how that's spread amongst people can change. But one thing that you will often see is a lot of successful startups, for example. If you look at like the 2 to 3 founders, there's a really even distribution of this kind of background and knowledge. And that's not a coincidence. Another really good example of this was Sun. So like hacker, hustler, hipster. Kelton is like a super brilliant designer. John had a background in engineering, but also an MBA and a business degree. He was awesome at getting people to throw money at us. And I was good at building electronics and designing software really quickly. And then I worked really well for us.
Database has been updated.
Something's been updated. Yeah, so, and then I also want to give an example of when it didn't work out well for me. So this was a project called LiveTech that I thought about spinning off into a company my senior year. Basically, the idea behind this was the check-in process for hotels is a pain in the butt, especially for business travelers who do it a lot. And I thought it would be great if you check in on your phone, you get to the hotel, you don't have to go to the front desk, you right to your room and your phone is your room key. It seems simple enough, right? We built it, it works. It is actually quite awesome. We won a bunch of awards for it, but this team was hacker, hustler, hustler, hustler. And so it was very unevenly weighted, and basically we couldn't decide on business plans, and it was too hard to organize everything and bring it together in a cohesive manner. So I ended up deciding not to pursue that, and I did open source this project, and it's on my website, and now actually a bunch of hacker spaces around the world use this as the entry system for their hacker spaces. So you can basically email entry keys to people, and they can use their phone to get into this space without a physical key. You can read more about that online. And then so that brings me to where I'm at now, which is, my official title is I am a hardware astronaut at Google X, because I'm responsible for, Google X's motto is that we take technology moonshots. So we do things that are 10x improvements over what's available in the world right now. So Astro, who's not his real name unfortunately, but Astro, who's the leader of Google X, our captain of moonshots. The way he usually describes it is, if you have a car and your car gets 40 miles a gallon and you want it to get 50 miles a gallon, you tweak your car a little bit, right? Like you adjust the engine, you make it a little bit more efficient, okay, you get 50 miles a gallon. if you have a car that gets 40 miles a gallon and you want to get 400 or 4,000 miles a gallon, you can no longer just be making tweaks. You have to completely rethink what a car is and how it works and redesign it from the ground up. And so that's a lot of the thought process behind Google X, which is basically we take Google's ability to throw an enormous amount of money and resources at a problem and use that to completely rethink the way we solve certain problems. So I think the glass team is actually an excellent example of a combination of these three things. So here, in this case, it's hacker, hustler, hipster. Isabel's our lead industrial designer. I work with her every day. Very, very smart, really good eye for design. And then we have our lead engineering architect and our lead product manager. And they all do a really good job of balancing each other out. And so for us, that's worked out well in that my daily job description is basically, so I design electronics for glass. Part of that time is spent in kind of the medium term, working on the next version of our hardware, working with our manufacturing folks, designing new hardware platforms. And then a large chunk of that time, and increasingly more and more of that time, because they want me to spend more time on this, is doing far out prototyping work. So thinking like 5 to 10 years in the future, what do we want glass or some other device or whatever we're doing to be able to do? How do we want to enable people to interact with technology? And then what do we need to invent to make that happen? And then so I handle that from the electrical side and try to invent that technology basically. And every day to do that, I work very closely with user experience designers and industrial designers and product mechanical engineers, software engineers. And it's really a combination of all those people that make this possible. I have background in mechanical engineering. I can write software, but ultimately, if you have people who are experts working together, you get to an end goal much faster. And so this brings me to some of my unsolicited advice for all of you, which I'm going to tell you whether or not you want it. So these are things that have worked well for me in terms of it's hard to say in hindsight which of these things have worked out well for me and which haven't. So I only know where I'm at now. I don't know exactly what necessarily caused it. But these are kind of mottos and things I do that I think have allowed me to be relatively successful in college and in the real world with people asking me to come work for them and things like that. So the first thing is being fearless. I started posting videos on YouTube in 2006, basically like the first year that YouTube was in existence. And one of the things back then, I don't know how well it's gotten better, but it's still an issue, right? Which is like all the negative comments and just overall crappiness that goes on in the internet in general. And a lot of people get dissuaded by this kind of thing. And the internet, posting stuff on the internet is just one example of this, but in general, people having negative feedback, something you're doing. So you want to do something, you're really excited about it, you want to make it happen, and inevitably there are always some people who are naysayers who say, that's stupid, this is ridiculous, why are you doing this? There's always, 100% of the time going to be some of that. So part of how I measure my success is my ability to ignore those people and decide for myself whether or not I think something is worth doing. So when I say be fearless, it means sometimes you should expect that people are going to have different ideas than you about whether or not something is a good idea or whether or not you should do it or whatever. But if you want to do it and you think it's exciting, you should do it and you shouldn't let those people stop you. Because my suspicion is that a lot of good ideas throughout history have never come to fruition because someone listened to someone who they shouldn't have. And they should have just kept trucking along and not listened to negative opinions about it. So this is a video of me acting like an idiot, essentially. After this Airbnb advertisement. The mouse is frozen. So this was my Halloween costume last year, and basically, so I was riding around the Google campus, and I don't know how many of you have like seen pictures of like the Google campus and offices and stuff. So we have these bikes around campus. It's a pretty big campus, and I broke my arm riding a bike on my second week there, and so my arm was in this cast, and I wanted to make a Halloween costume out of it, and I was like, all right, I gotta do something with the cast. So I decided to turn my arm into a spaceship. I 3D printed a rocket ship that fit over the cast. And then I decided that I would be space. And so I put a bunch of LEDs on my shirt and hook them up to an analog input that samples random noise, and then uses that to make them twinkle like stars. So this is, we can fast forward through some, although the 3D printing part is kind of cool sped up. I got really into time-lapse photography when I was at MakerBot because we did a lot of these kinds of shots and they're really fun. So anyway, the gist of it is at the end of this video in a minute, you'll see me running around the room and just overall like making a fool of myself. Inevitably with stuff like that, you're gonna get people saying like, what are you doing? Like, what's wrong with you? Like, do something more productive with your time. I actually learned a lot doing this project. I've been wanting to try to do sewable electronics, so I was using conductive thread. I've tried to do this like 4 times and failed. And I was like, this time I'm like, okay, I'm gonna sew stuff into a shirt and it's gonna work. And so it did. And so this is the part where I can create. You can't see it very well, but you can see me. I'm running around. This is me in my living room with my camera on a tripod, and I'm running around alone, like through the air, like this, and it's ridiculous. But I made a very conscious decision to ignore the fact that people would say it's ridiculous because I don't care. It ended up being a really fun project, and I had a really good time working on it, and I personally learned a lot. And these are the kinds of projects that have gotten me attention. So that people come to me, and so like I don't have to go out and look for a job. People come to me and say, Jeremy, you should come work at Google X and design a class. And I was like, okay. So that kind of stuff usually, in my opinion, doesn't work that well. Second thing is being, it goes along the same vein, which is being memorable. And so what I mean by being memorable is doing things and documenting them in a way that people say, wow, that was super cool. I want to work with this person. I want to be involved with something this person is working on. I want to be part of it. So I would say an example of that project was, well, I'll give you the full background here. When I was finishing my undergrad, I was out for dinner with my best friend from college the night before we graduated, and we were out for dinner, and I had never been to a graduation ceremony before, and we were talking about what a lot of people like to do is the mortar boards the graduation has. People like decorate the top of them because there's thousands of students out in the field, and all the parents are up in the bleachers, and it's really hard to see like where your kid is. So if you put something obvious on here, it makes it easier for the parents to find where you are. So people would, put their initials in there in styrofoam or wrap it in aluminum foil and do things like that. He's like, yeah, I'm surprised you're not doing anything. I was like, oh, I didn't know that was a thing. He's like, you should put lights on it. And I was like, okay, I can put lights on it. This was the night before, so it was just like 3 hours. I don't have a picture of it here. This is a different one, which I'll get to in a second. This was just I had an Arduino. I had a bunch of LEDs. I glued them to the top of my hat, and it made patterns, and it was fun. And I made it in 2 hours. But it was totally not visible at all in sunlight, so it kind of didn't really do anything useful outside. And it was fun, but it was something that I hacked together in a few hours. So as soon as I finished that, at this point I had already decided I was going back for an additional year to do my master's, and so I would have another graduation ceremony in a year. And I was like, okay, now I know I've got a year to make something as utterly ridiculous as possible. So that's this. So this was actually, the thing up here was actually the prototype for that sun lighting system I was talking about, but I had an extra one that I had made anyway, and I had it laying around. And the nice thing about it is that lighting system is designed to be a really high intensity light for a room. So to give you an idea of how bright this thing is, the average LEDs that you guys are working with on your breadboard consume somewhere from 5 to 20 milliamps on average, and you know how bright they are roughly. So on here, I had 16 LEDs, each capable of consuming up to 700 milliamps. So this thing was like a spotlight. I wore a laptop battery in a backpack to power all of it. This thing on my wrist is a Raspberry Pi with a controller and a screen, and it's wired up through my robe up to the hat. And this is connected to the internet, because what good is LEDs on your hat if they're not capable of tweeting? So, so the way this is set up is I set up a mobile website. Anyone in the audience could go to the website and choose a color, and it would put it in a queue, and then set the hat to that color. And when the hat turned to that color, it would tweet at that person saying, "I just set it to your color." And so a few hundred people controlled it over the course of the day. It was a lot of fun. And then I had like manual override for rainbow mode and doing fun things like that too. It was a very memorable project. I got, there was a fair amount of press on it, and Engadget and Gizmodo and those kinds of websites, Reddit. And I got a non-trivial amount of like job offers from this, basically. So that's the memorable thing there. If you do something that's really interesting and exciting, people will take notice of it. Next thing is being part of a community. So you guys already have this down pat because you have BlueStamp community, and that's awesome. And when I was in high school, nothing like this existed. So I had to do a lot of it online, and it was hard. And it's gotten a lot easier now, and you guys have that going for you. So you should realize how lucky you are to have like this room full of like-minded people who want to do awesome things. But it used to be a lot harder. And so I spent many years kind of building up a community of people who trusted my opinion on things and would watch my videos or would read my blog and cared what I had to say, basically, because I proved that I was legitimate. And so like a few months ago, for example, with my book, I decided that I wanted to give back to that community, and I said, hey, all of my holiday sales for the book, I'm going to donate 100% of the royalties from it to STEAM education causes. Ultimately, if I didn't have this community behind me, I would have, it would have been like a few $100. But I raised $4,000 from it, it's made a visible impact in the organizations that I've given it to. So that was really exciting, and I wouldn't have been able to do that without connecting to other people. And you can do that both in the virtual world and in the real world. And I would say the more you can do it in the real world, the better, because so many things are moving into just doing it in the virtual world. But when you actually connect to someone in the real world, it's a lot more real. And so a lot of the support I got from this and people retweeting it and sharing it as an initiative that I was trying to do were people who I knew in real life from things like BlueStamp, instructors and things like that. Working out of your comfort zone. So this was the Replicator 1, which is the precursor to the one that you guys have. That's a circuit board on the bottom with my name on it. And this was basically like, I came into the company, they didn't really have any like electrical engineers. I wasn't done with my electrical engineering degree yet. I had never designed something for mass manufacturing. And they were like, oh, design electronics for this, redo it from scratch. I was like, okay. I didn't have any idea what I was doing. We did it, and it worked. And there's a lot of things I learned from it, and a lot of things that I would never do again, and things that I would do differently and better, and I have done differently and better. I could have just as easily said, no, I don't have experience doing that. I don't feel comfortable designing this. But instead, I said, okay, I'll figure it out, and we'll make it work. And I was really uncomfortable with it at first because there was a lot of pressure on me. But in the end, I'm glad I did it because I learned a tremendous amount from it. And like when I was interviewing at Google, they explicitly told me one of the reasons they hired me was because I had specific experience bringing consumer electronic designs to market, which, I mean, that was this. So if I had said no, I also wouldn't have ended up at Google. So working out of your comfort zone, really important. I suspect a lot of you are already doing that with your BlueStamp project, but I encourage you to do it more. And along the lines of what I was saying before, I encourage you to work out of your assumed discipline too. So that means if you feel like you're a really mechanically inclined person, try some electronics, try some software. And then in general for engineering, I encourage you when you get to college, but also now, to seek out people who are who would consider themselves to be of the artistic type, although I'm sure many of you consider yourselves like that as well. Find people who are more on the design end of things, who are more on the art end of things, who care about communications and business and those kinds of things that maybe you don't care as much about, and find out why they find them interesting. And I bet you'll learn something really significant, and that will help impact your ability to do your work. And I found that to be true over and over and over again. And then this is somewhat contradictory to the last slide, but it kind of goes along with it, which is do what comes naturally. So it's good to work out of your comfort area, but I'm sure a lot of you also have a specific area that you feel like this is what I'm really good at. Like, I'm really good at writing code. I'm really good at building things with my hands. And it's also okay if you don't know what comes naturally yet, because that's what you have like the next X years of your life to figure out. You don't have to know it now.